Imagine if we could teleport reality into the virtual world, constructing detailed three-dimensional structures from a collection of simple two-dimensional images. That's exactly what the art, science and technology of photogrammetry enables us to do. By measuring and interpreting a series of images, we bring 3D objects to life. These are not just virtual copies, they are digital embodiments of physical entities rich with valuable information about the objects and their surroundings. Our journey begins in the mid-19th century with a German architect named Albrecht Meydenbauer. This is the man who gave birth to the term photometrography, later renamed to photogrammetry, using it as a blueprint for architectural plans. But from these humble origins, photogrammetry was destined to take flight. Fast forward to the 20th century and the wings of aviation carried photogrammetry to new heights. The world wars became a hotbed for photogrammetric advancements, fueled by the urgent demand for strategic planning and battlefield surveillance. Then, in the aftermath of the wars, photogrammetry pivoted from military might to commercial power, revolutionizing the fields of civil engineering and architecture. As computers started buzzing in the 60s and 70s, digital photogrammetry took the reins. Automation dialed up both accuracy and efficiency, opening doors to more complex analysis. Geolocation data courtesy of GPS tech added another layer of precision to this digital revolution. Today, photogrammetry is a critical tool across myriad domains, from archaeology to game design, from movie magic to architectural marvels. Cutting-edge technologies like drones and advanced digital cameras have made photogrammetry a household name, while innovations like NeRF or neural radiance fields continue to redefine the limits of this field. From its quaint beginnings to its high-tech evolution, the story of photogrammetry is as multifaceted as the 3D models it produces. As we navigate deeper into photogrammetry's world, we're introduced to the perspective geometry principle, concept that mimics our everyday visual perception. Just like how we perceive objects as smaller when they are far and larger when they are near, giving us a sense of depth and distance. Triangulation sits at the heart of photogrammetry, a map and compass style mechanism that pinpoints locations from two known positions. Coupling this with stereoscopic vision, the natural phenomenon that lets us perceive depth and arc distances, photogrammetry transforms 2D images into tangible 3D objects. But the puzzle gets a little more complex. Each camera, each lens has its unique thumbprint. Factors like focal length, sensor size, pixel size, lens distortion and the precise position of the camera all come into play, dictating the accuracy of the final model. Next up is the processing phase, where photogrammetry puts on its detective hat. Software identifies unique patterns or features within images, cross-referencing them to establish coherence. The final reveal comes in the form of 3D reconstruction, where matched features morph into a lifelike model. This starts as a point cloud, which, like a sculptor chipping away a block of marble, is gradually refined into a mesh, then textured with original photos to create realistic texture. In essence, photogrammetry bridges the gap between the flat world of photography and the dynamic realm of three-dimensionality. However, like any art form, the final result depends heavily on the quality of the raw materials, the images, and the meticulous application of these principles. Photogrammetry, while cost-effective and powerful in capturing large-scale landscapes, is reliant on good lighting and distinctive surface features. On the other hand, LiDAR or laser scanning uses laser pulses to measure distances. It shines in varying lighting conditions and accurately captures the large structures. But this precision comes with a hefty price tag. Structured light scanning projects linear patterns onto the subject to recreate its 3D form. Ideal for capturing small, intricate objects, it's less suited for outdoor or larger landscapes. Photometric stereo captures multiple images from the same viewpoint under different lighting. It reveals exquisite details and textures, but it calls for tightly controlled lighting conditions. Finally, there's NeRF, or neural radiance fields, the new kid on the block, which leverages machine learning to transform 2D images into 3D models. Despite its potential, NeRF demands hefty computational resources and time for model training. As you can see, each technique has its strengths and limitations, reflecting the diverse array of methods for capturing our world in 3 dimensions. The right choice depends on your project requirements, the size and complexity of the object, resources available, and the desired level of precision. Just like a magician pulling a rabbit out of a hat, photogrammetry conjures up incredibly detailed 3D models from a simple 2D images. From designing video games that feel eerily real to creating movie magic in Hollywood, photogrammetry has made the leap from science to our screens. Architects and engineers use it as a hidden hand in their designs, capturing buildings, structures, and environments in a level of detail that would make Da Vinci envious. Surveys, construction monitoring, renovation planning, all can be done from behind the screen, with photogrammetry working quietly in the background. Descending into the labyrinth of history, archaeologists use photogrammetry as their digital whip and fedora, preserving and studying relics of the past without even touching them. We are unearthing our history while ensuring it survives for future generations to explore. In the world of crime scene investigation, photogrammetry becomes the ultimate witness. It recreates scenes with an uncanny level of detail in the virtual world, scrutinizing every detail, helping detectives uncover the truth. Aerial photogrammetry gives us a bird's eye view, creating intricate topographic maps and keeping a vigilant eye on environmental changes. It's our eye in the sky, constantly mapping the ever-evolving face of our planet. In the world of manufacturing, photogrammetry is the strict quality control inspector, meticulously capturing every detail and detecting any deviations from the intended design. And let's not forget the realm of virtual and augmented reality. Here, photogrammetry serves as a bridge between the digital and physical worlds, weaving together immersive experiences that challenge the boundary between what's real and what's not. But the spell of photogrammetry can only be as potent as the images it conjures from. The journey from the shutter click to the final reveal requires precision and skill, every step influencing the grand finale. Despite its limitations, the possibilities of photogrammetry are boundless and are only set with each new discovery. Photogrammetry in the grand tapestry of 3D reconstruction is both cost-effective and versatile. It masterfully uses commonly available tools to metamorphose 2D images into high-resolution 3D models. Non-intrusive by nature, it finds applications from the preserving of historical monuments to the creation of virtual realities, flexing its adaptability with ease. However, like any hero, photogrammetry has its Achilles heel. The outcome of the process is heavily reliant on the quality of the initial images. Lighting, clarity, resolution, they all matter. Smooth, reflective surfaces or objects lacking distinct textures pose significant challenges. The processing of complex 3D models can be resource-intensive and time-consuming. Photogrammetry, like a stage play, demands controlled conditions. Consistent lighting and a stable scene are key to achieving accurate results. But every day, photogrammetry is growing, overcoming these challenges and enhancing its capabilities. In future videos, we will dive deeper in some of these topics. This will include the mathematics of photogrammetry. We will step into a world ruled by numbers and equations, where photogrammetry finds its beating heart. We'll unravel the mystery of perspective geometry and triangulation, twin pillars that transform 2D images into a 3D marvel. Unmask the crucial roles of camera parameters and learn how to mitigate errors to deliver the best results. We will also have a look at a detailed photogrammetry workflow. There you can join us on a journey that tracks photogrammetry from its initial spark to its final reveal. Learn why every detail matters, from the right gear to capturing the perfect image. Witness the transformative power of post-processing as raw images bloom into a textured 3D model. Of course, we will also be looking at other 3D scanning techniques. So you can explore the wide universe of 3D scanning, traverse the landscape of laser scanning, structure lighting, and photometric stereo, each technique offering unique opportunities. Contrast these techniques with photogrammetry, understanding their differences and similarities. With AI having a huge hype, you can expect a video where we will dive deep into NeRF, or neural radiance fields, a groundbreaking technology that combines artificial intelligence with photogrammetry. will demystify the training of a NERF model and illuminate current limitations and future potentials of this flaming new frontier. Great reality brings great video games, that's why we'll have a look at those too. Photogrammetry in video game development. Expect a thrilling odyssey through the digital worlds of video game development where photogrammetry breathes life into fantasy. Learn how this technology reduces costs, saves time and enhances the realism of games to create unparalleled immersive experiences. But we are not done yet, because there are so many more applications of 3D scanning. Therefore, let's discover them. From forensics to quality control, architecture to topographic mapping and archaeology, see how 3D scanning surmounts challenges in these diverse fields. We've just started to scratch the surface of the rich tapestry of photogrammetry. We've taken a peek at the fundamental principles, explored its different types and compared it with other 3D scanning techniques. Photogrammetry's applications are as diverse as they are profound, and its impact is felt from the immersive world of video games to the historic relics of ancient civilizations. But the journey is far from over. In our upcoming series, we'll delve deeper. We'll explore the fascinating mathematics behind photogrammetry, unravel its complex workflow, and investigate the avant-garde NERF technology. So buckle up and join us as we continue our adventure into the captivating world of photogrammetry. Thank you for being part of this journey, and I'm looking forward to exploring more together in the coming videos.